Problem number 54. The speed of a transverse wave on a string is 115 meter per second when the string tension is 200 Newton. To what value must the tension be changed to rise the wave speed to 223 meter per second? So in this question, we are going to find the value for tension. So, but clearly it shows that we have to use the rule here, the speed of the wave on a string, which is given by the rule V equal to square root of T over mu. So this rule we have to use here. But what is exactly given in this question? The wave had the speed 115 by the time the string tension is 200 Newton. And in the second part, what they give, if you want to increase the wave speed to 223 meter per second, how much tensions we have to apply to the string? That's a concept. So that means V1 value here is 115 meter per second by the time your tension T1 value is 200 Newton. And then if your wave speed is 223 meter per second, what should be the value for tension given to the string? And if you want to find the answer for this T2, we have to apply this rule. So what I'm going to do, I'm going to frame this formula for these two different values of the speed as well as the tension. So for that, better we can write this equation without the square root because we have to find the value for T2. So better we can discard the square root. So if you want to avoid the square root, what we have to do, we have to squaring this equation both left hand side and right hand side. So if you squaring, what you will get? V square, which is equal to T over mu. So the equation will be like this. So now what I'm going to do, I'm going to apply this rule for these two sets of data. So let's apply this equation here. So if you apply this equation, what you'll get? So first I'm going to apply this equation for this set. So I can write this equation as V1 square, which is equal to T1 over mu. So let's take this equation as 1. And again, I'm going to apply this rule for the second set of the data. So V2 square, which is equal to T2 over mu. So let's take this equation as the second equation. And here the most important thing, your linear density, because the same string we are going to use, so the linear density will not be changed. So that's the reason we are going to write this linear density as it is as mu. Because once you work out to find the answer for T2, by the time this mu will get cancelled each other. So now what I'm going to do, I'm going to divide the second equation by the first equation to get the answer for T2. So let's divide. So divide equation 2 by equation 1. So if you divide, so let's divide in the left hand side. So V2 square over V1 square, which is equal to T2 over mu over T1 over mu. If you rearrange these equations, we will get this equation as V2 square over V1 square, which is equal to T2 over mu multiply mu over T1, right? So we can cancel this mu both upside and downside. So by that, the equation will have the different form. So V2 square over V1 square, which is equal to T2 over T1. The main thing, we are going to find the answer for T2. So we have to rearrange this equation in terms of T2. So let's rearrange. Therefore, the above equation will get the new form as T2, which is equal to T1 multiply V2 square over V1 square. So now let's substitute the value for T1, V1 and V2. So let's go back to the question to get the value for T1, V1 and V2. So what's the value for T1, which is 200, and V1 is 115 and V2 is 223. Now I am going to substitute this value here. So let's substitute the value here. So T2 equal to T1 takes the value of 200 Newton, which is already given in the question, multiplied by V2 square. So V2 value 223. So 223 square divided by V1 value is 115. So 115 square. So when you solve this part, so you'll get the answer for T2 here as 752.05 Newton. So if you want to rise the speed to 223 meter per second, how much tensions we have to give to the string? 752.05 Newton we have to give. So this is the answer for this question. That's it. Thank you.